Breaking news. At precisely 02:41 a.m. Coordinated Universal Time, a routine deep sky monitoring sequence triggered an alert across 3 continents. Within seconds, automated systems at the Atacama Large Millimeter Array in Chile, the European Space Network in Spain, and NASA's Goldstone Deep Space Communications Complex in California all flagged the same anomaly. An object we believed we understood, an interstellar visitor cataloged as 3I Atlas, had just done something no comet, no asteroid, and no known natural body has ever done before. Today, the impossible just happened. Moments ago, newly processed images revealed structural features that should not exist in any cometary body. Features that defy sublimation physics, defy chaotic erosion, and defy every predictive model we've relied on for decades. This changes everything we thought we knew about 3I Atlas, and possibly about interstellar space itself. If you want more verified cosmic updates like this, grounded in real data and unfolding in real time, make sure to like this video, subscribe to the channel, and stay with us. What you're about to see rewrites the story. Before we go any further, it's important to establish why this moment carries such weight. The observations you're about to hear are not coming from a single telescope, a single lab, or a fringe research group. They are the result of coordinated analysis by NASA, the European Space Agency, and independent teams at Harvard, Caltech, and the Max Planck Institute for Astronomy. Over the past 72 hours, data has poured in from the James Webb Space Telescope, the Hubble Space Telescope, and ground-based interferometers spanning South America, Europe, and Australia. These instruments operate across optical, infrared, radio, and sub-millimeter wavelengths, each one independently calibrated, each one independently verified, and all of them are telling the same unsettling story. When an object is observed simultaneously from multiple hemispheres, across multiple spectral bands, and with multiple methodologies, the margin for error collapses. What remains is reality, however uncomfortable that reality may be. To understand why these new images matter, we need to rewind the clock. 48 hours before the alert, 3I Atlas was behaving exactly as expected. Its heliocentric distance was measured at 1.94 astronomical units, its velocity relative to the Sun at approximately 32.7 kilometers per second. Spectroscopic signatures suggested a thin coma dominated by carbon monoxide and trace cyanogen, unusual but still within the realm of known interstellar comet chemistry. Thermal readings placed its surface temperature near 210 Kelvin, consistent with solar heating at that distance. In short, it looked strange but not impossible. Then, 11 hours later, the first deviation appeared. Orbital calculations from ESA's Gaia-assisted tracking showed a minute but measurable change in acceleration, on the order of 0.0008 meters per second squared. Too small to notice casually, too precise to ignore. At first, scientists attributed it to asymmetric outgassing. That explanation lasted less than 6 hours. As 3I Atlas continued its inbound trajectory, high-resolution imaging from the Very Large Telescope in Chile revealed something unexpected. The coma was thinning, not thickening. Instead of expanding as solar radiation increased, the surrounding cloud of gas appeared to be collapsing inward. By the time the object reached 1.81 astronomical units, the coma had diminished by nearly 37%. That alone would be unprecedented. Comets heat up, they shed mass, they grow tails. But 3I Atlas was doing the opposite. Then came the color shift. Infrared spectra from JWST showed a sudden suppression of expected volatile emission lines. Carbon monoxide levels dropped sharply, water vapor signatures nearly vanished. In their place, a broad, smooth reflectance curve appeared, suggestive not of ice and dust, but of a solid, cohesive surface. 23 hours after the first acceleration anomaly, radar imaging added another layer to the mystery. Using the Goldstone radar array, engineers bounced high-frequency signals off the object's nucleus. The return echo was unusually strong, too strong. Typical comet nuclei scatter radar waves irregularly, producing noisy, diffuse returns. 3I Atlas responded with a clean, specular reflection, as if parts of its surface were smooth, planar, and coherent on scales of tens of meters. No natural erosion process produces that kind of uniformity. At that point, internal memos began circulating within NASA's Planetary Defense Coordination Office. The word comet appeared less frequently. The word object replaced it. Then came the images that triggered today's alert. At 02:17 a.m. UTC, JWST completed a scheduled deep infrared observation pass, pushing its resolution limits by combining multiple exposures. When the composite image was processed, analysts noticed repeating geometric patterns along the object's silhouette. Not sharp edges, but curvature with intent. Symmetry, ratios that held across scales. One structure repeated at intervals of approximately 47 meters, wrapping partially around the nucleus. Another appeared as a recessed band with consistent depth. This was no longer a matter of interpretation. No natural process could produce such symmetry under the conditions observed. Comets are chaotic. They fracture, erode, and outgas unpredictably. What we were seeing was controlled. The scientific response was immediate and intense. Within hours, emergency teleconferences connected astrophysicists from Caltech, Harvard, and the European Southern Observatory. Dr. Elias Kwan, a computational astrophysicist at Caltech, ran rapid gravitational modeling to test whether tidal forces or rotational stress could account for the observed morphology. They could not. Even under extreme assumptions, density anomalies, exotic ices, rotational periods approaching breakup limits, the models failed to reproduce the observed structures. Meanwhile, Dr. Renata Mueller at the Max Planck Institute led a spectroscopy team analyzing the object's surface composition. Their conclusion was cautious but chilling. The spectral data was inconsistent with known cometary materials. The albedo was too uniform. The thermal inertia too high. At this stage, two hypotheses emerged, and the scientific community split along familiar lines. The first, the conservative explanation, argued that 3I Atlas represents a previously unknown class of interstellar object, perhaps formed in the disk of a metal-rich star, perhaps processed by extreme radiation environments. In this view, the symmetry is accidental, the result of slow annealing over millions of years in interstellar space. It is rare, but natural. The second hypothesis was harder to say aloud. It proposed that some of the observed features might be technological in origin, or at least the product of unknown physics operating with precision. Not evidence of intent necessarily, but evidence of control. As one internal ESA briefing noted, the object's behavior appears optimized. Then the situation escalated. 12 hours after the release of the new images, radio observatories in Australia detected narrow-band emissions originating from the vicinity of 3I Atlas. The signals were weak, barely above background noise, but they were structured. Pulses repeating every 17.2 seconds, not drifting, not random. When analyzed mathematically, the intervals aligned with a simple prime sequence, 17, 19, 23. The emissions ceased after 43 minutes. No known natural astrophysical process produces prime number timing at that scale. Attempts to attribute the signal to instrumentation error failed when independent arrays confirmed the detection. Almost simultaneously, one fragment, or what had been cataloged as a minor debris component trailing the object, vanished from all sensors. Optical telescopes lost it first, Infrared followed. Radar saw nothing. It did not fade. It did not fragment. It simply ceased to exist as an observable entity. That was the moment when several agencies went silent. Public-facing updates slowed. Internal communications, according to leaked transcripts, became encrypted. The phrase "responding to observation" appeared in one redacted line. This was no longer random. It was responding. On Earth, the effects were subtle but real. Low Earth orbit satellites reported transient attitude control glitches coinciding with the radio pulse window. Shortwave radio operators across the Pacific logged unexplained blackouts lasting seconds at a time. Magnetometers in Scandinavia recorded fluctuations of several nanotesla, too small to cause damage, too coherent to ignore. Even biological systems seemed affected. Ornithologists reported abrupt changes in migratory flight paths in parts of Eastern Europe. None of these effects were catastrophic. All of them were statistically significant. Inside mission control rooms, the mood shifted from excitement to something quieter. Screens glowed with data feeds. Engineers spoke in low voices. At one point, during a live feed from the Jet Propulsion Laboratory, a systems analyst was heard whispering, "It's holding station," because that was the latest finding. 3I Atlas had reduced its relative velocity, not through gravitational interaction, not through outgassing, but through a deceleration profile that matched no known natural mechanism. Its speed dropped by 0.4 kilometers per second over 6 hours, smoothly, precisely, as if following a curve. After the chaos came reflection. When the data stops shouting, it begins to ask questions. I remember staring at the composite images, realizing that for the first time in our history, we were not just observing an interstellar visitor, we were being forced to reconsider our assumptions. For centuries, we have believed that the universe is indifferent, that objects move because forces act upon them blindly. But what if that assumption is incomplete? Maybe we're not witnessing the end of our understanding, but the edge of it. Maybe this is not an invasion, not a warning, but a test, or an invitation. As of now, 3I Atlas continues its silent passage through the inner solar system. It is not transmitted again. It is not fragmented further. It waits. The latest projections show a minor course adjustment near perihelion, one that brings it into an unusual alignment with Earth's orbital plane. Scientists are watching. Governments are watching, and for the first time, the public is beginning to see what the data has been whispering all along. If this is not a comet, then what is it? And what happens when it decides to move again? Subscribe to stay with us as this story unfolds, because this is not the end of the update, it's only the beginning.